All right, so what we're going to do now, we're going to start getting a little more advanced and taking a look at arguments where we may not necessarily know whether it's valid or not. All right, so this says for all x, if it's f, then it's g. This thing a that's in our universal discourse is g, therefore a is f. And that should seem a little bit suspect to you right away. Okay, like this says if it's f, then it's g, not if it's g, then it's f, right? But let's say we didn't really have any intuitions about this and we went about trying to prove it. We went about trying to get a derivation. All right, well, I don't know. I guess we would use universal elimination on line 1. I mean, that's always a good thing to do if if you're stuck. And I don't know, I don't see any way to get from here to here. We could try assuming not FA. That still doesn't really get us anywhere. It looks like we're kind of stuck, right? But the thing is by using PD, by using the derivation system, no matter how long we sit there and we grind away at this and we try to get a proof, if we can't find one, it just shows that we haven't found one. It doesn't show that this argument is invalid, right? So what we need to do, so we can sit here and we can keep working on this. I think we should stop. I don't think this is going to work. It's probably an invalid argument. So in order to show that, so remember, a valid argument is one where there's no interpretation, there's no possible interpretation where the premises are all true and the conclusion false. So if we can build even one such interpretation, if we can show even one such interpretation, we have a counterexample, and we've shown this argument to be invalid. And I think that's probably the route we should go with this. Let's try to see if we can show it to be invalid. So let's sketch ourselves a little model, a little like visual model to work with. Okay, so we have the extension of f and the extension of g. Well, we know that whatever a is in g, so let's say a is Albert, okay? Albert is in G, and this says, this is true. We need to make this true and this false. This is false already. Albert is in G. Albert is not an F. Right? This says if it's F, then it's G. That's already true. There's no counterexample. There's nothing that's F and not G. But if we wanted to make that a little more clear, we can put something in here. Let's say Betty's in there. So Betty's F and G, so everything that's F is G. Albert's G, but Albert's not F. So we're done. We have a counterexample. We built an interpretation where these are true and this is false. So all we have to do is kind of formally spell out what's in the counterexample. Because remember, this is just kind of like a little sketch for us. It's not actually like a proof. So what's in our universal discourse? Albert and Betty. All right. What's in the extension of F? Betty. Or more formally, the ordered tuple with Betty in it. What's in F and G? Or sorry, excuse me, what's in G? Well, G's got two things in it. Albert and Betty. All right. So now we just need to say what the constants that we're using are picking out. A is an name of Albert in this interpretation, and we're done. This is the formal description of what we sketched here, and this is a counterexample to this argument.